It's only the third one ever. There's, 1.5 million known asteroids, and there's about 35,000 near-Earth objects.
Why would the U.S. Space Force suddenly shift a launch window without explanation, right as an interstellar comet cut across the solar system? July 1st, 2025. Chile's Atlas survey spots something extraordinary racing toward us. Not from our neighborhood, not from anywhere in our solar system. This is 3I/ATLAS, the third confirmed visitor from deep space. Here's what makes this terrifying. These objects are rarer than winning the lottery twice. We've only seen two others in all of human history. Oumuamua in 2017, 2I/Borisov in 2019. Now this. But here's the kicker. As 3I/ATLAS blazed through our solar system, something unusual happened with America's most secretive launch operations. Space Force missions, typically locked down to the second, experienced mysterious scheduling adjustments. Think about this. Military launches are usually rigid, precise, calculated to the second. So, why adjust a window? And why now, when an alien comet just arrived? That's what we're digging into. This isn't your typical space rock. 3I/ATLAS moves at 130,000 miles per hour. That's twice the speed of the first interstellar visitor. It follows a retrograde orbit, backwards, compared to everything else in our solar system. NASA's Hubble telescope captured it on July 21st. The images show something that sent shivers through the scientific community. A bright coma of dust and gas, growing larger as it approaches our sun. But what really caught attention wasn't just the comet itself, it was the timing. April 2025, months before 3I/ATLAS was even discovered. Space Force authorities made sudden changes to an Atlas V launch window. Weather, they said. Range scheduling conflicts. Yet seasoned aerospace reporters noticed something odd. The explanation felt incomplete, too vague for such a critical military operation. Now we know 3I/ATLAS was already out there, racing toward us at unimaginable speed. Did Space Force know something they weren't telling us? Or is this the most incredible coincidence in space history? What we're about to uncover will change how you think about both interstellar visitors and military space operations forever. The hidden decision. Here's where things get interesting. The redirect wasn't announced in any press release, no fanfare, no explanation to the media. But aerospace insiders noticed. They always do. Launch schedules are public information. When an Atlas V mission suddenly shifts its window, people pay attention, especially when the official reason sounds rehearsed. Range scheduling conflicts, weather concerns, standard explanations that usually satisfy reporters. But not this time. Because behind the scenes, something far more sophisticated was watching. The Space Domain Awareness System. Most people have never heard of it, but it's America's most advanced network for tracking objects in space. Think of SDA as the ultimate cosmic security system. Radars like the space fence on Kwajalein Atoll can detect objects larger than a baseball moving anywhere near Earth. Every piece of debris, every satellite, every asteroid, and yes, every interstellar visitor racing through our solar system at 130,000 miles per hour. Here's what's fascinating about SDA. It doesn't just track objects passively. It analyzes trajectories, predicts close approaches, calculates potential risks to American space assets worth billions of dollars. When 3I/ATLAS entered the outer solar system, SDA computers immediately began tracking its path. Not just for scientific interest, for national security. Because here's what most people don't realize. Interstellar objects represent the ultimate unknown variable. They don't follow predictable orbits like asteroids or comets from our solar system. They arrive without warning, move in unexpected directions. For military planners, that's both a nightmare and an opportunity. The nightmare? An unpredictable object potentially interfering with classified satellite deployments or reconnaissance missions. Imagine launching a billion-dollar spy satellite only to have an alien comet's debris field compromise the mission. But the opportunity? That's where things get really intriguing. 3I/ATLAS represented something unprecedented, a live test case for America's space defense systems, a chance to practice tracking a truly alien object under real conditions, not a simulation, not a drill, the real thing. Some believe this is exactly what happened in April 2025, that Space Force seized on 3I/ATLAS as the ultimate training exercise. Test the SDA networks, practice launch window adjustments, see how quickly they could respond to an interstellar threat. If this was only about safety, why not just say so? Launch delays happen all the time, weather scrubs missions constantly. Technical issues force postponements, unless the real reason was classified. Unless admitting they were using an alien comet for military exercises would reveal too much about America's space defense capabilities. The timing makes perfect sense now. April's mysterious launch delay, July's discovery announcement. But here's what really sends chills down your spine: the new questions. But what if the real concern wasn't the comet itself? What if it was what the comet could leave behind? At 130,000 miles per hour, 3I/ATLAS isn't just fast. It's weaponized by physics. Every fragment that breaks off becomes a hypervelocity projectile. A piece of ice the size of a marble could punch through a satellite like paper. This is the nightmare scenario keeping Space Force planners awake at night. Not the comet hitting Earth. NASA already confirmed 3I/ATLAS poses no direct threat to our planet. But space is different. Up there, everything matters. A fleck of paint can crack a space station window. Debris from old satellites has already forced astronauts into emergency shelters. Now, imagine fragments from an alien comet moving twice as fast as anything we've ever tracked. Here's the thing: a single fragment of ice or rock from this comet, moving faster than a bullet, could tear through a satellite. Imagine the stakes if that happened during a launch. We're talking about billion-dollar military satellites, GPS systems that guide everything from smart bombs to your Uber ride, communication networks that keep our forces connected worldwide. One collision, one fragment in the wrong place at the wrong time, and America's space-based infrastructure could face catastrophic damage. But here's what makes this even more chilling. 3I/ATLAS doesn't just move fast. It's shedding material as it approaches the sun, creating a debris trail that stretches for millions of miles. Telescopes around the world have confirmed it. The Hubble Space Telescope captured images showing a growing coma of dust and gas. The ESO Very Large Telescope documented the formation of an actual tail. This isn't just pretty space photography. It's evidence of an active debris field expanding through our solar system. What do you think? Was this a simple coincidence, or was the military testing a response to something much bigger? Drop your thoughts below before we reveal what could really be at stake. Because if you're into uncovering the mysteries behind rare space events and military secrecy, hit subscribe. We bring you stories you won't hear on the evening news. The answer lies in understanding how modern space warfare really works, and why 3I/ATLAS represents the perfect enemy for training purposes. Military implications. The timing lined up too closely to ignore. April's mysterious launch window shift, July's comet discovery. But now, we know the full picture. Space Force operates under classified protocols most civilians never hear about. Launch window corridors can be shifted to avoid even low-probability risks. When you're dealing with billion-dollar assets, even a 1% chance of collision becomes unacceptable. But here's where military thinking gets fascinating. What if they didn't just avoid 3I/ATLAS? What if they used it? Some defense analysts believe Space Force conducted a collision avoidance exercise using 3I/ATLAS as the trigger, not because they were scared of the comet, because they wanted to test their response systems under real conditions. Think about it from a military perspective. When else would you get a chance to practice tracking an actual interstellar threat? These objects visit maybe once every few years. Missing this opportunity would be strategically negligent. The exercise would be simple but invaluable. Track the incoming object, calculate debris field expansion, identify potential collision windows, then practice shifting launch schedules in real time, all while maintaining operational security. No public announcements, no detailed explanations to reporters, just quiet adjustments that only insiders would notice. This aligns perfectly with current Space Force doctrine. The 2023 Space Policy Directive explicitly treats planetary defense and near-Earth monitoring as national security priorities. Not just scientific curiosities, America's competitors are watching. China's space program launches military satellites monthly. Russia maintains extensive orbital surveillance networks. Both nations study how America responds to unexpected space events. Revealing too much about 3I/ATLAS tracking protocols could expose classified capabilities. Show rivals exactly how sophisticated our space domain awareness systems really are. This wasn't just about a comet, it was about proving America's ability to respond to the unknown. Because here's the terrifying reality. 3I/ATLAS won't be the last interstellar visitor. And the next one might not be so harmless. The next one might arrive with less warning, move even faster, or follow a trajectory that actually threatens critical infrastructure. When that day comes, the lessons learned from 3I/ATLAS could mean the difference between maintaining space superiority and watching our satellite networks burn up in alien debris fields. But there's something even more disturbing about this entire situation. Something that suggests the military knows more about interstellar objects than they're telling us. Patterns in interstellar visitors. Let's talk about something that should absolutely terrify anyone paying attention to space. We're seeing a pattern. Each interstellar visitor is stranger than the last. October 2017. Oumuamua arrives from deep space. Astronomers immediately notice something wrong. It's accelerating in ways that defy physics. No visible tail, no gas emissions. Yet, somehow speeding up as it moves away from the sun. Scientists scramble for explanations. Solar radiation pressure, they say. Outgassing we can't detect. But the numbers don't add up. Oumuamua behaves like nothing we've ever seen. Then comes 2I/Borisov in 2019. This one looks more normal at first. Acts like a proper comet. Forms a tail, sheds gas and dust. Scientists breathe easier, until they analyze its composition. The chemistry is all wrong. Water ratios that don't match anything in our solar system. Carbon monoxide levels that suggest formation in temperatures no solar system should reach. Borisov didn't just come from somewhere else. It came from somewhere with completely different rules. Now we have 3I/ATLAS. And this one breaks every remaining assumption about interstellar objects. The retrograde orbit alone should be impossible. Objects don't just randomly flip direction in interstellar space. Something had to cause that trajectory. Some force or event we can't even imagine. At 130,000 miles per hour, it's moving faster than any natural object should. Twice the speed of Oumuamua. As if it's not just passing through our solar system, but fleeing from something. Are we seeing a pattern, each object stranger than the last? Each one challenging our understanding of what's possible in space? Every time one of these visitors arrives, we scramble to study it. Telescopes around the world focus on the new arrival. Scientists publish papers analyzing every detail. But here's the catch. The military is watching too. And they may be preparing for something astronomers don't like to say out loud. What happens when one doesn't just pass by? Because that's the real question keeping defense planners awake at night. Not whether these objects are natural or artificial. Not where they come from or why they're so strange. The question is simple and terrifying. What happens when one decides to stay?
Houston, we have a problem. I don't think this is Florida. Luckily, I didn't need NASA. I needed a legal army. It turns out there's an injury firm called Morgan & Morgan, America's largest injury law firm, with over 1,000 attorneys and more than 100 offices nationwide. I tried calling one of those local lawyers with cheesy jingles. I was on hold longer than a Mars launch delay. Meanwhile, Morgan & Morgan helped a client in Florida get $12 million after the insurance company only offered $350,000. Morgan & Morgan only gets paid if they win your case. No upfront fees. You can file a claim right from your couch or from the jungle. Here's how easy it is. You can just click the link in the description or scan the QR code on screen. If you're ever injured, you can check out Morgan & Morgan. Their fee is free unless they win. You can start your claim by clicking the link below or scanning the QR code on screen.
3 visitors in 8 years, each more bizarre than the last, each arriving with less warning and moving faster than predicted. If this is a pattern, we're not prepared for what comes next. And the most chilling part? The next discovery could force us to stop launches entirely. What could be at stake? Imagine this scenario. It's 2026. Another interstellar object appears on our detection systems. But this one isn't just passing through. Its trajectory shows a close approach to Earth, closer than the Moon. Every launch stops immediately, not just military missions, commercial satellites, crew rotations to the International Space Station, supply missions to lunar bases. Everything grounds until the threat passes. But what if it doesn't pass? What if this visitor follows a capture orbit, trapped by Earth's gravity into a permanent elliptical path around our planet? Suddenly we're sharing space with an alien object we can't predict or control. Launch windows become nightmares of orbital mechanics. Satellite deployments turn into collision avoidance puzzles. The entire space economy freezes. This isn't science fiction. This is the scenario keeping Space Force commanders awake at night, because we're completely unprepared for a long-term interstellar visitor. Our space traffic control systems barely handle the 34,000 objects we're already tracking. Add an unpredictable alien artifact to the mix, and the whole system could collapse. But here's what makes this truly terrifying. We might not get much warning. 3I/ATLAS was discovered just 3 months before its closest approach to Earth. Oumuamua was spotted after it had already passed the Sun. Our detection systems are impressive, but they're not magic. An object on a direct collision course with Earth might give us weeks to respond, maybe days, possibly hours. That's why the classified data matters so much. We see NASA press releases showing beautiful telescope images. We read scientific papers analyzing comet composition. But SDA radar's track details will never know. Precise trajectories, rotational characteristics, structural integrity assessments, material density calculations, all classified to protect operational capabilities. What they aren't telling us may be even more important than what we see through telescopes. Because every interstellar visitor teaches us something new about detecting the next one, about predicting trajectories, about calculating risks to critical infrastructure. The April 2025 launch window adjustment wasn't just about avoiding 3I/ATLAS. It was about learning to respond when avoiding isn't possible. When the stakes are $1 trillion space economy, when failure means losing GPS, communication satellites, and weather monitoring systems that keep civilization running. When the next visitor might not be content to just pass by and wave goodbye. The pattern is clear. The visitors are getting stranger. Our responses are getting more sophisticated. And somewhere in classified briefing rooms, military planners are preparing for the day when peaceful observation becomes active defense. That day might be closer than anyone wants to admit. Now, let's dive into what makes 3I/ATLAS so scientifically extraordinary. Because the military implications are just the beginning. July 1st, 2025. The Atlas Survey Telescope in Chile spots something moving against the star field. At first, it looks like any other faint dot of light. But the calculations reveal something impossible. This object is moving at 130,000 miles per hour relative to our Sun. That's not just fast. That's escape velocity from the entire galaxy. Nothing bound to our solar system could ever reach such speeds naturally. The orbital mechanics tell an even stranger story. 3I/ATLAS follows a hyperbolic trajectory. Think of it as a straight line barely curved by the Sun's gravity. Most comets follow elliptical orbits, returning every few decades or centuries. But this visitor is on a one-way trip. It came from interstellar space. It will return to interstellar space. And it's traveling backwards relative to everything else in our solar system. Retrograde motion is incredibly rare. It suggests 3I/ATLAS formed in a completely different stellar environment, one where planetary formation happened in reverse compared to our system. Then comes the composition analysis. As 3I/ATLAS approaches the Sun, solar heating begins sublimating its surface ices. Telescopes worldwide detect something fascinating. This comet is unusually rich in carbon dioxide ice, not water ice like most solar system comets. CO2 requires extremely cold formation temperatures, colder than anywhere in our solar system during planetary formation. The Hubble Space Telescope captured the moment sublimation began. July 21st, images show a bright coma of gas and dust expanding around the nucleus. By late August, the ESO Very Large Telescope documented actual tail formation. But here's where the science gets truly revolutionary. Isotopic analysis of that tail could reveal chemistry unlike anything we've ever seen. Think of it as a time capsule from another star system, frozen for millions of years, and now melting in front of us. Every atom in 3I/ATLAS formed around a different star, under different conditions, with different elemental abundances. When we analyze its isotopic ratios, we're literally reading the chemical signature of alien stellar nurseries. Carbon-12 versus carbon-13 ratios, oxygen isotope abundances, nitrogen compositions that could only form in specific stellar environments. If those ratios don't match solar system standards, we'll have proof that stellar formation processes vary dramatically across the galaxy, that our sun and planets represent just one possible outcome among countless alternatives. But the isotopic analysis reveals something even more profound: the age of the material itself. Solar system comets formed 4.6 billion years ago from the same primordial disk that created Earth. But 3I/ATLAS could be far older, or far younger. Its chemistry might record stellar events that happened before our sun even existed, or after our sun dies. We're not just studying a comet, we're analyzing a messenger from deep time and deep space. A physical sample of cosmic evolution delivered directly to our telescopes. And all of this is happening while military radars track every fragment it sheds, while defense planners calculate collision probabilities, while classified algorithms model worst-case scenarios. Science and national security converging around a single alien visitor racing through our cosmic neighborhood. To understand why 3I/ATLAS matters so much, we need to look at its predecessors, because every interstellar visitor has rewritten our understanding of what's possible. October 19th, 2017. Astronomers at the University of Hawaii spot something extraordinary: an object moving too fast to belong to our solar system. They name it Oumuamua, Hawaiian for scout or messenger. At first glance, Oumuamua looks like an asteroid, dark, rocky, cigar-shaped, about the size of a football field. But as telescopes track its path, something impossible happens. It starts accelerating, away from the sun, without any visible tail or gas emissions that could explain the thrust. Scientists scramble for explanations: solar radiation pressure pushing against its surface, invisible outgassing of hydrogen, exotic ice compositions sublimating without detection. Nothing fits perfectly. Oumuamua remains the most mysterious object ever detected in our solar system, a visitor that broke the rules and left more questions than answers. 2 years later, astronomer Gennady Borisov discovers the second interstellar visitor. 2. I/Borisov behaves more like a traditional comet. Forms a proper tail, sheds gas and dust as expected. But spectroscopic analysis reveals its own shocking secrets. The chemical composition doesn't match anything in our solar system. Water ratios suggesting formation temperatures far below what our outer planets experienced. Carbon monoxide abundances that require stellar environments completely unlike our sun's protoplanetary disk. Borisov came from somewhere with fundamentally different chemistry, different physics, different rules for how planets and comets form. Now we have 3I/ATLAS, the third confirmed interstellar visitor in human history. And it's the strangest yet. faster than both predecessors, following an impossible retrograde orbit, shedding material that could represent completely alien stellar chemistry. Each visitor teaches us something new about interstellar space, about stellar formation, about the diversity of planetary systems across the galaxy. But they also teach military planners something crucial. These objects arrive without warning, move unpredictably, and represent completely unknown variables in space traffic management. Oumuamua forced creation of new tracking protocols. Borisov revealed gaps in our detection systems. Now, 3I/ATLAS is testing our response capabilities under real conditions. Every new interstellar object forces both scientists and military planners to adapt, to expand detection networks, to improve tracking algorithms, to develop response procedures for increasingly exotic scenarios. So, here's the bigger question. Are these just random visitors, or are they warnings that space is far more unpredictable than we thought? 3 visitors in 8 years suggests interstellar objects might be common, far more common than we realized, which means our detection systems are capturing only the largest, brightest examples. Smaller objects could be passing through constantly, too faint for our telescopes, too small for our radars, but large enough to destroy satellites or derail launch missions. The pattern is becoming clear. Interstellar space isn't empty. It's full of travelers, ancient wanderers ejected from distant star systems, cosmic nomads carrying the chemical signatures of alien worlds. And some of them are headed our way. The April 2025 launch window adjustment wasn't just about one comet. It was about preparing for a future where interstellar visitors are routine, where space operations must account for the impossible becoming inevitable. Because if the pattern holds, 3I/ATLAS won't be the last surprise visitor. It might just be the beginning of a cosmic parade that changes everything we thought we knew about our place in the galaxy. So, here's what we know. April 2025, Space Force quietly adjusts a launch window. The official explanation feels incomplete. Range scheduling conflicts, weather concerns, standard reasons that usually satisfy reporters. But they don't explain the timing. July 2025, 3I/ATLAS discovered racing toward us at 130,000 miles per hour, already deep in the solar system, already being tracked by classified radar networks, already posing theoretical risks to billion-dollar space assets. The launch window shift remains quiet, unexplained, but perfectly timed with the comet's arrival. Coincidence? Maybe. But the evidence suggests something far more sophisticated happened behind closed doors. Space Force operates the most advanced object tracking network in human history. The Space Domain Awareness System monitors everything larger than a baseball orbiting Earth. Those same radars extend their reach far into interstellar space. When 3I/ATLAS entered the outer solar system, SDA computers immediately began calculating trajectories, not just for scientific interest, for national security implications. Whether the April launch adjustment was pure coincidence or deliberate preparation, this moment reveals how military secrecy intersects with rare cosmic events, how classified protocols respond to unprecedented scenarios, how national defense adapts to threats we never imagined. Because this is just the beginning. 3 interstellar visitors in 8 years suggests these events aren't rare cosmic accidents. They're becoming routine, each visitor stranger than the last, each one testing our detection systems, each one forcing military planners to expand their definition of possible threats. Oumuamua accelerated without explanation. Borisov carried alien chemistry from distant star systems. Now, 3I/ATLAS races backwards through our solar system at impossible speeds. The pattern is clear. Space is far more unpredictable than we thought. Our cosmic neighborhood receives regular visitors from the deep galaxy, ancient wanderers carrying messages from stellar environments we can barely imagine. And some of them might not be content to just pass by. The next interstellar visitor could arrive tomorrow, could follow a trajectory that actually threatens Earth, could move fast enough to give us hours instead of months to respond. When that day comes, the lessons learned from 3I/ATLAS could mean the difference between successful planetary defense and cosmic catastrophe. The Space Force knows this. The classified briefing rooms where these decisions get made understand the stakes. They're preparing for scenarios that would terrify most civilians. Scenarios where launches stop entirely, where satellite networks face destruction from hypervelocity debris, where Earth's space-based infrastructure becomes collateral damage in an interstellar encounter. Whether the April 2025 launch window shift was coincidence or deliberate, it represents something profound. The moment when military space operations acknowledge that our solar system isn't isolated, that threats can arrive from the deep galaxy without warning, that the next visitor might require responses we haven't imagined yet. The universe is vast, ancient, full of wanderers ejected from distant star systems billions of years ago. Some of them are headed our way. Some of them are already here. And military planners are watching the skies, preparing for whatever comes next. If you don't want to miss the next discovery, because we're only at the beginning, hit subscribe and turn on notifications. The next visitor could change everything we know about space and our place in it. Because somewhere in the darkness between stars, another ancient traveler is racing toward our solar system, moving faster than we think possible, carrying secrets from stellar environments we've never seen. And when it arrives, we'll be ready. Thanks to the lessons learned from 3I/ATLAS and the quiet decisions made in classified briefing rooms where the future of space defense gets written. The question isn't whether more visitors are coming. The question is whether we'll be prepared for what they bring with them.